Hi there. Well, welcome to the first lesson for Math 11, Apprenticeship and Workplace Math 11. And this starts off with talking about slope and rate of change. So we did a little bit of this in grade 10 if you remember rightly. The main thing about slope was that it was the rise over the run on a slope. So let's just scroll down here, and you see that we're going to talk about ratios and proportions to begin with. So I'm going to try and make these lessons as brief as possible and just hit the highlights. So just bear with me while I bring up some tools here. Okay. Now, it's talking about here a ratio. A ratio is actually a comparison between two numbers measured with the same units. It gives an example of a car engine running on a mixture of oil and gas. And this car needs 15 liters of gas for every 1 liter of oil. So basically the ratio is a 15:1 ratio of gas to oil. So you can write this as 15:1, you can write it as 15:1, or you can write it as a fraction. It's all the same thing. It's all a ratio. A proportion is a statement of equality between two different ratios. So they're talking about this ratio and this ratio. These two ratios are equal. Here we have an engine that needs 15 liters of gas to 1 liter of oil, or an engine double the size would need 30 liters of gas to 2 liters of oil. Okay, so let's just move on, clear that, and scrolling down. Here's an example in your notebooks here, and it goes through this example, and it's giving you a recipe for vegetarian chili, and you can read the recipe here. Won't bore you with the details, but what is the ratio of corn to kidney beans? That's the first question, and then the ratio of tomatoes to kidney beans. So simply notice that they're asking for corn first to kidney beans. So if you're going to write a ratio, you want corn to kidney beans, or corn divided by kidney beans. So here it is. Kidney beans, as you can see, is 30. Oh, sorry, corn. Corn is 15. Kidney beans 30. So it's going to be 15 to 30 as it says right here. Now, you can simplify this ratio. Obviously 15 to 30 can be reduced. If you wrote it as a fraction, 15 divided by 30, you can see that this they're both divisible by 15. So you can reduce it to 1 over 2, and that's what they've done. They've divided both the 15 and the 30 by 15 till it becomes 1 to 2. So that's the smallest whole number ratio that is equivalent to 15 to 30. It gives you an alternate solution below, so I'll let you look at that. And scrolling down, we come to the second part, part B. The part B was talking about ratio of tomatoes to kidney beans. So if you looked, tomatoes were 56 ounces, kidney beans were 30, so you can write 36, so 56 to 30. And again, you can reduce this ratio. This can be reduced, they're both divisible by 2 at least, and you can see it turns into 28 to 15, smallest whole number ratio. Okay, so on the next page you've got some questions to answer, and I'll let you do this in class when you get there. And these are build your skills. So basically based on the previous examples I've just gone over, you can do these questions. Next example on page 12 talks about a big screen TV has an aspect ratio of 16 to 9, which means for every 16 inches of width, it's 9 inches high. Well, it's asking what is the height of a TV that's 40 inches wide. Well, we already have this ratio, 16 to 9, and that is width to height. So they're giving you width to height, and they're saying it's 16 to 9. They're also giving you, letting you know that they've got a TV that's 40 inches wide. So they've got 40 inches wide, but what's its height? What is its height? So 40 to something, they're calling it x here. But we know it's the same ratio as the one they've given us, 16 to 9. So 40 to x, whatever the height is the same as 16 to 9. So we've got to calculate x here. Different ways to do this. So let's see what they're doing. They're basically, they are multiplying both sides by 9x, 9 and x. If we do that, these x's will cancel. So that cancels with that. And if they're multiplying by 9x on this side, the 9's will cancel. So that means it'll be 9 times 40 here equals 16 times x. And now if you divide both sides by 16, you're left with x. So this gets divided by 16. And doing this calculation right here will give you the answer below of 22.5. Some of you might know it. If you've got one fraction equaling another single fraction, you can say that this is the pair, multiply the pair, 40 times 9, and that equals, multiply the pair divided by the spare. So divide that by 16, and that will give you the value for x. 16 is a spare because we don't know, we can't pair it up with x because we don't know what x is. Another way to look at this is that top times bottom, 40 times 9, will equal this top times this bottom, 16 times x. And then from there you can divide both sides by 16. 16's cancel here and here to leave just the x value of 40 times 9 divided by 16, which is what they end up here. So different ways to do the same problem. Make sure you know how to do this in a calculation. It will come up time and time again if you don't see me in class, but look over this example I've just given you. And now you want to carry on now and do the build your skills questions here, 4, 5, and 6. On page 13, new skills, working with slope. So remember, slope is vertical distance divided by horizontal distance. This little triangle just means change in vertical distance divided by change in horizontal distance. So if you start here and you end up here as you travel, you go from here to here. To find out the slope, how big a slope this is, you need the change in vertical distance. So in other words, the rise till you get to the same height. And the run, so this is the rise, this is the run, or change in vertical distance that you go through to go from here to here, and the change in horizontal distance that you go through in going from here to here, called the run. It's typically called m. They use this variable m when they talk about slope. So here is the formula right here, if you remember from grade 10. Example below talks about calculate the slope of a line that has a rise of 12 and a run of 8. So it's rise over run, it's 12 over 8. And so that just becomes 12 over 8. And you can reduce because they're both divisible by 4 to give 3 over 2, or in decimal form 1.5. By the way, you can go back and look at any of my calculations. Pause the video anytime you want, or repeat. If you missed a point, if it went too fast for you, So they get the same answer here. Okay, so yeah, pause and rewind the video if you missed something. So an alternative solution here, have a look at that. And then I'd like you to do these questions here in class. Of course, anytime you want, you can always start these questions ahead of time at home before you come to class. Here's an example 4. So here in example 4, the slope is 7/20. What is the rise? I want to know the rise. If the run is 100 meters. Okay. Rise over run. We know already 7/20. That's in least or smallest whole number ratio. Now, what is the rise? We don't know the rise. The rise over the run. They tell us the run is 100. So this ratio of unknown to 100 meters of run must be the same as the slope, 7/20, which they give us. Okay, you can do different calculations here. They show you how to do it one way. The reason they multiply both sides by 100 here is that the run is 100. So this run is 100 and it cancels with this. So rise equals 100 times 7/20. If you set it up like this, the way I have, you can say that top times bottom equals the other top times bottom, or 20 times x. Now we have to divide both sides by 20, so x will be 7 times 100 divided by 20. Another way to look at it, multiply the pair, divide by the spare. And we get the answer of 35. Okay, so if you would just go ahead and answer the last few questions here to 10 in class tomorrow. So I'd like you to read over example 5 here. You should have a good idea of what's going on now. And probably you'll be working on these also in class tomorrow. So up to page 18 and complete that page for class. And that ends lesson 1. Okay, let me know how this goes for you in class tomorrow. Thanks.